Chapter number 17, Development of the Human Eye, page number 633. Anterior chamber and aqueous outflow pathway. The slit-like space that results from the ingrowth of the first wave of mesenchymal cells, the future corneal endothelium, and the posterior extension of the second wave of cells, the primary pupillary membrane, from the rim of the optic cup forms the beginning of the anterior chamber of the eye. Further development of the anterior chamber depends on the differentiation of the structures that border it, namely lateral displacement and deepening of the angular region, differentiation of the angular tissues, differential growth of the cornea that increases its spherical curvature relative to the sclera, and the eventual location of the lens behind the developing iris. Angle of the anterior chamber. By approximately 7 weeks of gestation, embryo 22 to 24 mm, the angle of anterior chamber is occupied by a nest of loosely organized, undifferentiated mesenchymal cells that are destined to develop into the trabecular meshwork. The posterior aspect of the angle is defined by mesodermal cells that are developing into the vascular channels of the pupillary membrane, as well as by loose mesenchymal cells and the pigment epithelium of the forward growing optic cup, which will form the iris. Anteriorly, the corneal endothelial cells extend to the angle recess, and by the 15th week of gestation, these cells meet the anterior surface of the developing iris, thus demarcating the angle of the anterior chamber. At this stage, the corneal endothelium lining the chamber angle may be composed of several cell layers, but the cells flatten toward the root of the iris. By the 5th month, the anterior chamber angle is rounded, and this configuration persists until about the 7th month. The angle recess shows a progressive deepening that commences at about the 3rd month of gestation and probably continues for a considerable time after birth, up to the age of 4 years. As development proceeds, the recess of the anterior chamber angle appears to move posteriorly as a result of a differential growth rate of the various tissue elements. This process results in the repositioning of the ciliary muscle and processes, which initially overlapped the developing trabecular meshwork, and the entire ciliary body becomes located posteriorly to the meshwork. By 7 months gestation, the deepest part of the angle has receded to the level of Schlemm's canal, but at the time of birth, the apex of the angle is located beyond the canal and is at the level of the scleral spur. The angle at birth differs from that in adulthood because more of the uveal portion of the trabecular meshwork is located anteriorly to the ciliary muscle and in front of the scleral spur. Additionally, the angle is open to the anterior face of the ciliary body. With the posterior displacement of the angle, the apex, that is, the ciliary band of gonioscopists, is formed primarily by the anterior face of the oblique and circular muscle fibers. The anterior face of the meridional muscle bundle is obscured by the scleral spur. Chapter number 17, Development of the Human Eye, page number 633, figure number 17.20. Light micrograph of an eye of an 11-week-old fetus in meridional section. At this stage, the angular region is ill-defined and occupied by loosely arranged spindle-shaped cells. The canal of Schlemm is unrecognizable, and the ciliary muscles and processes are not yet formed. The ciliary processes will develop from the neural ectoderm at the rim of the optic cup. In bracket, asterisk, bracket complete. The corneal endothelium appears continuous with the cellular covering of the primitive iris. AC, anterior chamber. L stands for lens. Original magnification 230 times.